So this video is from section 4.9, and it is on graphing quadratic inequalities. So you actually, everything in this section should be very familiar to you. You know how to graph a quadratic function, you know how to shade with inequalities, so this should be a piece of cake. So the steps involved, and go ahead and pause and jot down these steps if it will be helpful, but the first step is to graph the parabola with the given equation. Okay, so now this is technically going to be an inequality, so I'm just going to jot this down. But you want to, for just a second, of course, ignore the inequality and just kind of graph the parabola. So other things you're going to want to remind yourself is if it has an equal sign underneath that inequality, you're going to have a solid parabola. If there's no equal sign underneath it, you're going to have a dash parabola. And I'm sure you're okay with that, but if not, remind yourself. After you graph the parabola, step 2 is to test a point to determine where to shade. Unless you know where to shade, of course, you can always test a point. And then last but not least, if you have more than one inequality to graph, you have to shade where the solutions work for all inequalities, both or all of them. And we'll go through an example, of course. All right, so we'll start out with a single quadratic inequality here. So y is less than or equal to negative x squared plus 2x plus 3. So it's in standard form, and we need to graph it first. So I'm going to find the vertex. So since it's in standard form, I'm going to use the opposite of b divided by 2a. So the opposite of b is going to be a negative 2 divided by 2 times a is negative 1. So x is going to be negative 2 divided by negative 2, which is a positive 1. Then if I go back up here and put in 1 for all of the x's and simplify, that's nice and easy. Be careful with the negative. So I have a negative, but then 1 squared. 1 squared is 1, but it's still negative. So negative 1 plus 2 plus 3. So that's going to be 4. So my vertex is 1, 4. And this is a great review of graphing because we haven't graphed since the very beginning of the chapter. So if this is like jogging your memory, you should probably start, go back now before the test comes. So I know that my vertex is at 1, 4. I'm just going to zoom in here so that I can draw a nice vertex. So there we go, 1, 4. And I know my pattern of change is a times 1, 3, 5. Well, a is negative 1, so it's going to be negative 1, negative 3, and negative 5. So again, from my graph, I know that I'm going to go over 1, down 1, over 1, down 3, over 1, down 5. Same thing in the other direction, over 1, down 1, over 1, down 3, over 1, down 5. Now before I make my parabola, I'm going to go back and reference that I do have an equal sign underneath that inequality, so it is going to be a solid parabola. So I'll go ahead when I connect these, and I will make a solid parabola. Now I want to either shade inside or outside the parabola, and some of you will just note that it is less than or equal to, so that would be below or inside, in this case, the parabola. If not, test a point, and 0, 0 is always a really easy point to test, and it's not, my parabola is not going through there, so I can certainly test 0, 0, so I'm going to do that real quick up here, testing 0, 0. So I have 0 is less than 3 is what that's going to amount to, and that is a true statement. So I do want to shade the point 0, 0, which is right there, so that's going to be everything inside that parabola. So nothing unfamiliar to you. You know all these steps. You know how to graph it, you know how to test points, you know how to shade, and you are done. All right, this last one is a system of quadratic inequalities, so that means more than one. Although the process is identical to graphing 1, now you're going to graph 2 and make sure that the intersection of the shaded regions is highlighted. So I have them color coordinated, so the first quadratic is in red, and that one is in standard form, you probably note. So because it's in standard form, I can find the vertex by using the opposite of b over 2a. So notice that there is no b value because it's x squared and then there's no x term, so it's going to be 0 divided by 2 times 1. Well, 0 divided by anything is 0. So the x-coordinate of the x-coordinate of the vertex is 0, and then if I put 0 in for x, I think that's pretty obvious up here. 0 squared is 0, minus 2 is negative 2. So the vertex is going to be 0, negative 2. The a value is 1. So that means the pattern of change will be 1, 3, 5. Okay, so the vertex is at 0, negative 2, and the pattern of change is 1, 3, 5. So it's going to be over 1, up 1, over 1, up 3, over 1, up 5. And then from the vertex, I go the other direction, over 1, up 1, over 1, up 3, and over 1, up 5. Now, before I connect this parabola, again, note that it is there's no equal sign, so it's going to be a dashed parabola, so you don't want to connect your parabola. And then it does not go through the origin, so you could test 0, 0, or if you know it's greater than, so it's going to be inside the parabola. I think that's, you know, you're probably fine to be at that point. But if I test 0, 0, I end up with 0 is greater than negative 2, which is true, so I do want to shade inside that parabola or towards my test point, which was 0, 0. Now I'm just going to draw arrows so that I don't make a mess. Okay, and then I'm going to graph my second parabola, which is also in standard form. So its vertex, the opposite of b, which would be a positive 3 divided by 2 times a, which is negative 1. So that's going to be negative 3/2. And then the y-coordinate, if I plug in a negative 3/2 for all of the x's, be careful. Note that negative 3/2 squared is going to be a positive, but then this negative will negate it. Again, this negative times this negative will be positive. So just be real careful with your signs. Obviously, you know, I'll walk through this real quickly, but you, if you have your calculator, that might be a little quicker too. So, but I'll work down here, work through that. So a negative 3/2 squared is a positive 9/4, but then the negative up front will negate that, so that's going to be negative 9/4. Negative 3 times negative 3/2 will be a positive 9/2, and then plus 4. So I need a common denominator. This, of course, would be if I did not have a calculator. So that's over 1, so the common denominator would be fourths. So 9/2 as a fourth would be 18. 4 as a fourth would be 16/4. And then, of course, I can add my numerators. And that's 25/4. So my vertex, I'll just go up here, is negative 1.5 and 25/4, which of course is 6 1/4. So I'm going to approximate this, which is totally fine. So I'm going to go to the left about 1.5, and then up 1, 2, 3, 4, 5, 6, and a little bit more, so about 6 1/4, and there's my vertex. Now the pattern of change here is a negative 1, 3, 5, so I'll put that down here, negative 1, negative 3, and negative 5. So from my vertex, I'm going to go over 1, down approximately 1, over 1, down 1, 2, 3, over 1, down 1, 2, 3, 4, 5, and then of course I'll do that in the opposite direction and reflect that. Then notice that there is an equal sign, so it's going to be a solid parabola. And it is a less than or equal to, so I know it's going to be shaded inside. Or if I didn't know that, again, good old 0, 0, since my parabola is not going through there. So I'll squeeze it in here. 0 is less than 0 squared is 0. 3 times 0 is 0, plus 4. So is 0 less than or equal to 4? And yes, it is. So I would shade that one towards 0, 0 also. So you can see now that the red is shaded all here. The blue is shaded all here, so I need you to shade for sure where they would intersect, which is just this piece right here. If you do shade both of them instead of doing the arrow method like I just showed, that's totally fine as long as you kind of highlight the region where they would intersect. And that's it. Nothing to it.